Today, guys, we're going to talk about types of fits. Okay, so here are the three types of fits that we deal with. We have the clearance fit, which basically is when the two objects have a little bit of wiggle room in between them. Okay, so it's a very loose fit. Okay, it says here's the official version is the clearance fit limits the size of mating parts so that a clearance, so an opening, always results when mating parts are assembled. Okay, and then interference fit is, of course, a tight fit. Okay, they don't really go together well. You kind of got to really push it in to place. And so let's see, the official version is interference fit limits the size of mating parts so that an interference always results when mating parts are assembled. So that's an interference fit. Okay, they'll always cause you problems for each other there. Okay, transition fit can kind of go in between the two, and we'll see what that looks like here in a minute. So here we go. We're going to have, basically, let's just pretend that's a dowel rod there. And you got your hole over here. All right, so if we're looking at that, in this case, we have the dowel rod going into the hole, of course. And when it goes into that hole, if we look at this, no matter what happens, there's always going to be a little bit of wiggle room left in here. Okay? There's always going to be a little bit of space when I go ahead and put that dowel rod in. And how I can determine this is, let's say we make the dowel rod as big as it'll go. Okay? So as big as it'll go is 10. Okay? 10 inches. Okay? Well, at the smallest size this hole will go, that'd be 10.15, is still not smaller than 10. So even at the smallest the hole is and the largest the peg could be, there's still going to be 0.15 inches in space in between them. So there will always be wiggle room. That is a clearance fit. Interference fit is obviously the opposite here of the clearance fit. When these two go together, they're always going to overlap a little bit. So it's going to take, breaking out the mallet and knocking this dowel rod in again. So here we have the dowel rod again. It's not how you spell dowel. There we go. And then you have your hole over here. Okay. And when we take that dowel rod and we put it into the hole, what's going to happen is it's always going to interfere. Okay. Because if we look this time, let's make that dowel rod as small as we can. Okay. The smallest size that dowel rod can be is 9.92. Well, let's make that hole as big as we can. Okay, so we're trying to make some clearance in between the two. But the biggest I can make that hole is 9.9 inches. So no matter what I do, there's still going to be 0.02 inches of interference in between those two. Okay, so let's look at the last one here. And this is the transition fit. This one can kind of go either way. So if we look at let's make the dowel rod as large as it can go, 10.15 inches. And let's make the hole as small as it can go, and that would be 10 inches. Well, here, if the dowel rod is 0.15 bigger than the 10-inch hole, then obviously in this case we would have an interference fit. But let's back that up for a second. Now let's try to make that dowel rod as small as possible. Okay, 10.05. And we want to make the hole as big as possible. Okay, to see if these guys overlap still. And that's 10.12. Well, that hole is bigger than the smallest dowel rod. So there's a way we can put these two together and there's still some wiggle room. So when these guys fit together, they could have clearance, they could have interference. It depends on where the manufacturer fell within those tolerances. All right, so this is a transition fit. It can kind of go either way. All right, so there's this thing called MMC, which is maximum material condition. Okay, it's the condition when the part that we're looking at has the most material possible. All right, so they talk about an external feature here. An external feature, for example, would be our dowel rod. Okay, So if we're looking at the dowel rod's maximum material condition, this would be the upper limit of the tolerances, because the larger I make the dowel rod, the more material I need. Okay, the more material I use. Okay, now on an internal feature, which is like a hole, okay, the lower limit gives me the maximum material, because you think about it, if I have a block of wood here and I drill a hole into that block of wood, okay, the smaller the hole I draw or drill, okay, the more material I leave behind of that block. So if I drill a smaller hole, I leave behind more wood. Okay, so the lower limit, the smaller hole, smaller internal feature, gives me the maximum material condition. And then for the least material condition, the LMC, which we don't really use for what we're about to do here, but we're going to talk about it anyhow, is the smallest amount of material used. So for an external, that's going to be your lower limit. In other words, the dowel rod. We want it to be as small as possible to use as little material as possible. Okay? And then the LMC, the least material condition, for an internal feature like a hole, would be the upper limit. Okay? Because the bigger the hole, the less material that's left behind. And so we have the least material condition. All right, so allowance is the minimum clearance or maximum interference between the parts. Depends upon what kind of fit we're looking at here. Okay, so we'll get to that in a second, but here's your general formula for an allowance. It's the maximum material condition of the internal feature minus the maximum material condition for the external feature. So let's look at an example of this right here. And in case you don't remember, this one here, this dowel rod and this hole were the clearance fit from before. Okay, so if we look at the maximum material condition for the dowel rod, remember maximum material for the dowel rod would be the upper limit. And since the dowel rod is an external feature, that number, that upper limit, is actually going to go where the green is. Okay. Now, maximum material condition for the internal feature would be the lower limit, because remember, the smaller the hole, the more material I leave behind. So that's my maximum material condition. That's going to go in for my yellow number. Okay? So if I take that 10.15 and I subtract out 10, I'm left with a positive value of 0.15. So that means that's how much wiggle room I have left between the two objects. Okay, I have 0.15, okay, amount of wiggle room when we're using the most material possible. All right, that's our allowance. All right, now looking at this one. This one is our interference fit. Okay, and we're still going to use the same numbers here. So the maximum material condition for the internal feature, the hole, would be the lower limit, because remember, smaller hole leaves behind more material, maximum material condition. Okay, and for the dowel rod, our maximum material condition for the external feature, the dowel rod, would be the upper limit, because the larger the diameter of the dowel rod, the more wood we're going to use to create that dowel rod. Okay, so if we take the 9.85, that's our internal feature, and we subtract the 10, our external feature, we end up with negative 1.5. And the reason we end up with the negative 1.5 is because this is interference. They overlap each other by 1 or 0.15. So it's a negative because it's overlapping, hence interference. Okay? So another way of saying this is the maximum interference is 0.15. All right, kind of quick note here to summarize about tolerances. So when you're dimensioning tolerances, and I think I've mentioned this to the students in my class before, but the more significant figures, basically the more decimals you add onto the end, or decimal places you add onto the end of your tolerance, the tighter the tolerance. In other words, you're not going to give the manufacturer much wiggle room. It's really hard to get it that precise. Well, guess what? To get it that precise, it costs a lot of money, because you need very specific tools. You end up throwing out the parts that aren't to the tolerances, and it costs more to manufacture. So you don't want to overly give tight tolerances that are not necessary. Obviously, if you're building, say, a jet engine, giving those tighter tolerances, okay, giving those more significant figures is important. But say if you're building, I don't know, children's toy, it's not necessarily always needs to be as precise. There can be a little bit more wiggle room there. We wouldn't use the same tolerances to build a children's toy as to build a jet engine. Okay, so be very careful with that. Okay, and the last thing is if it's out of tolerance. Okay, basically it's not within those specified limits that we've been given. Okay, if it's out of tolerance, it's junk. Okay, and usually that's why you see the quality control people. You ever get one of those stickers on something that says like checked by number 12 or something like that? Okay, those are the quality control people who are checking those parts to make sure they fall in tolerance. Now, do you think they checked every part, or do you think they checked some of the parts? They probably took a sample, okay, and they checked to see if those samples fall within the tolerances. And if they do, they keep on manufacturing. If they don't, then they probably got to fix something. All right, at this point, you're going to finish up the activity. Good luck. If there was anything in these notes that you did not understand, please, please, please ask your teacher. Bye.